Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on finding confidence intervals on the mean. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. We will begin this video with an example. A random sample of flight times from city A to city B is taken and the times in minutes are listed below. Assume the flight times are normally distributed. Construct a 95% confidence interval on the mean flight time between city A to city B. Notice how we will tell what we need to do for this example. First, the directions for this problem can be found by looking for what I call the action verb. It will be the verb that tells you what the problem wants you to do. You're looking for the verb that says construct, find, create, something similar to that, or looking for the question mark that may ask how many. In our problem, that word is the word construct. It's telling us what to do. Another word I might use is the to-do verb. What is it wanting us to do? It wants us to construct. What does it want us to construct? It wants us to construct the confidence interval. Once you know that, you should then be able to pick out which of your formulas you need. It wants us to construct a 95% confidence interval on the mean flight time. So we know we're trying to construct a 95% confidence interval on the mean. The 95% is a number we'll need, and we know that we're doing the confidence interval on the mean. And we're doing it from city A to city B. And if we want to be more specific, we can say that's from Atlanta to Baton Rouge. Notice as well that instead of having a list of statistics being things that describe our sample, we do not have a mean and a standard deviation. Instead, we have the results from the study. We have data or flight times themselves from the sample flights. How do we know it's a sample? Because that first sentence says what? A random sample of flight times from city A to city B is taken, and the times in minutes are listed below. Remember that your best and first skill that you need in solving these problems is your ability to read. Read and reread the words. These words do not make up the normal word problems in the traditional algebra sense. You know, two trains leave the station heading in opposite directions. But they are word problems in that the directions are in the words, and you will have to find the clues to tell you what to do in the context of the words. Anytime that we have a list of data, what is the first thing that we want to do? We want to find the statistics, the summary of our data from the sample. The summary can be found by using one-var stats, and that I have covered in previous videos and will not do so in detail here. Placing the data in list 1 and then using one-var stats, we get the following information. The sample mean, or X bar, is given here, and we will round that to 4 decimal places, so X bar is given as 89.6471. For Miss Borlaug, all of her working numbers are rounded to 4 decimal places. Therefore, the sample standard deviation, S, is given as 3.6902. And we will have our sample size of 17. This will be all the statistics we will need about our sample. As we look at this problem, the first thing we want to determine before we proceed is whether our data is normal. This problem tells us assume the flight times are normally distributed. Therefore, we do not need to worry about having a large sample size, where a large sample size is a size of 30 or more. Because we do not know the population standard deviation, we will use the t-interval or the t-distribution. And our formulas are given on the screen. These formulas are usually given to you on your test. They will not be labeled problem to problem, but will be given to you as a set, or at least here at Walter State they are. We're not asking you to memorize these formulas. Your teacher may differ, so be sure to ask. If your teacher does give them to you, flashcards are a great way to learn to recognize the formulas and a way to know which formulas go to which type of problems. The formula can be placed on one side and the keywords and uses for them on the other side of the flashcard. Okay, through chasing that rabbit, back to constructing this confidence interval. Since we are 95% confident, our alpha is 0.05. The degrees of freedom, or n-1, is 16. And that gives us a t of alpha divided by 2. 0.05 divided by 2 is 0.025. And looking that up in our chart will give us 2.120. We will plug that in for our error formula, and the error gives us 2.120 times the standard deviation of 3.6902 divided by the square root of n, or the square root of 17. Calculating that gives us 1.8974, again rounded to 4 decimal places for our working numbers. We will now take X bar and add or subtract that error. And I'm not going to read those decimals out. You can do so yourself. But that, well, I guess I will. 89.6471 plus 1.8974 gives us 91.5445. And 89.6471 minus 1.8974 gives us 87.7497. And now I'm going to talk about the rounding of those two limits. We have our upper confidence limit and our lower confidence limit. And I am following this standard of rounding. Each teacher may have a slightly different set of rounding rules, so you will need to follow your teacher's rounding rules. For this video and for Mrs. Borlaug, she rounds these to one more decimal place than your original data. Therefore, these will be rounded to 91.5 and 87.7. And that gives us our upper and lower limits. Some teachers will want these written as an interval, and Mrs. Borlaug and others will want a sentence. The parts of your sentence that are always the same are here. I can say with blank % confidence that the blank is between blank and blank blanks. Now, all we have to do is fill in the blanks. And yes, there are a lot of blanks, but if you can look at it this way, it's just a matter of knowing what goes into each blank. The first or red blank is your percent of confidence. So it's very simple to fill in. In our case, that is 95% and comes straight from the problem. Again, reading is your friend. The next blank, or the black blank, is about your topic. What are we talking about? Are we talking about the height of pygmies? Are we talking about the weight of the pigs? Are we talking about the proportion of girls with pigtails? No, we're talking about the mean flight time between city A and city B. We're talking about the mean. That's how we knew to do the confidence interval on the mean. So we want to start with that word from our problem and follow along until we've described what we're talking about. So the mean flight time between city A and city B, and we're using those words from the problem exactly. Again, reading is your friend. It may be a little tedious, but it's not hard. The next blank, or the green blank, are the intervals, and we will fill those in with the lower and upper confidence limits from our calculations, and we just fill in the numbers. The last blank, or the blue blank, is the units blank, and we simply place here the unit that the numbers are measured with. In our case, that's minutes. Again, how long does it take to get from city A to city B? Is 87.7 measured in seconds, minutes, microseconds, years? Does it take 87.7 years to get from city A to B? Well, we need to know. It takes 87.7 minutes. And again, this comes straight from the problem. Notice again that reading is our friend. This problem cannot be done without looking back at the words of the problem. The answer is in the words as well as in the numbers. Here are some problems for you to try. I will give you the answers for each after a slight pause where you can pause and try to work it first before you see the answer. I will not give you the sentence. You will need to come up with those yourself. Remember that you will not receive, or remember to receive, full credit for these. If your teacher is using these as a quiz, you will need to show all your work and write the sentence. And I meant to mention it on the previous one where it gave you the statistics as opposed to the data, that for rounding, if the data is not given, we assume that the mean weight, in this case the mean weight of the dogs, is already been rounded to one more place, decimal place in the original data, so our interval is rounded to the same decimal place as the sample mean. I hope this video was helpful, and thank you for watching.